नमस्कार विद्यार्थी मित्रमैत्रिणींनो, स्वागत आहे तुम्हा सर्वांचं सपनाज होमस्कूलिंग या चॅनलमध्ये। आज आपण 10th स्टँडर्ड सायन्स 1चा फर्स्ट लेसन ग्रॅव्हिटेशनची एक्सरसाइज बघत आहोत। तर चला आपल्या व्हिडिओला सुरुवात करूया। फर्स्ट क्वेश्चन, स्टडी द एंट्रीज इन द फॉलोइंग टेबल अँड रीराइट देम पुटिंग द कनेक्टेड आयटम्स इन सिंगल रो। फर्स्ट, सेकंड, थर्ड, आता हे तीन आपल्याला रोज दिलेले आहेत। हा क्वेश्चन आहे, आपण याचा आन्सर पाहूया। आन्सर, फर्स्ट, मास ची जोडी kg बरोबर होते आणि ते आहे मेजर ऑफ इनर्शिया। सेकंड, वेट न्यूटन अँड डिपेंड्स ऑन हाइट। थर्ड आहे ॲक्सिलरेशन ड्यू टू ग्रॅव्हिटी, त्याची जोडी आहे ms²। आणि थर्ड जोडी आहे 0 ॲट द सेंटर ऑफ द अर्थ। फोर्थ, ग्रॅव्हिटेशनल कॉन्स्टंट nm² into kg², same in the entire. Second, answer the following questions. A. What is the difference between mass and weight of an object? Will the mass and weight of an object on the earth be same as their values on Mars, and why? Answer. The mass of an object is the amount of matter present in it. It is same everywhere in the universe and is never zero. It is a scalar quantity and its SI unit is kg. The weight of an object is the force with which the earth or any planet, moon or star attracts it. It is directed towards the center of the earth. The weight of an object is different at different places on the earth. It is 0 at the earth's center. It is a vector quantity and its SI unit is the Newton. The magnitude of weight is equal to mg. The mass of an object will be the same on the earth and Mars, but the weight will not be the same because the value of g on Mars is different from that on the earth. B. What are free fall, acceleration due to gravity, escape velocity, and fourth is centripetal force? Answer. Free fall. Whenever an object moves under the influence of the force of gravity alone, it is said to be falling freely. Second, acceleration due to gravity. The acceleration produced in a body due to the gravitational force of the earth is called the acceleration due to gravity. Note. On the Earth's surface, the value of the acceleration due to gravity is almost uniform. It is if a body falls from the low altitude, the value of the acceleration due to gravity is almost the same. Third, escape velocity. When a body is thrown vertically upward from the surface of the Earth, the minimum initial velocity of the body for which the body is able to overcome the downward pull by the Earth and can escape the Earth forever is called the escape velocity. Centripetal force. In uniform circular motion of a body, the force acting on the body is directed towards the center of the circle. This force is called centripetal force. C question. Write the three laws given by Kepler. How did they help Newton to arrive at the inverse square law of gravity? Kepler's first law. The orbit of a planet is an ellipse with the sun at one of the poles. Figure 1.4 shows the elliptical orbit of a planet revolving around the sun. ही आकृती आपल्याला पेपरमध्ये हा क्वेश्चन मोस्टली येतो, सो ही आकृती लक्षात ठेवा, कारण ही आकृती तुम्हाला काढायला येऊ शकते किंवा या आकृतीवरती प्रश्नही येतात पेपरमध्ये. Kepler's second law. The line joining the planet and the sun sweeps equal area in equal interval times. A to B, C to D, and E to F are the displacements of the planet in equal intervals of time. The straight lines AS, CS, and ES swipe equal areas in equal intervals time. Area ASB is equal to area CSG is equal to area ESF. Kepler's third law. The square of the period of revolution of a planet around the sun is directly proportional to the cube of the mean distance of the planet from the sun. Thus, if r is the average distance of the planet from the sun and t is its period of revolution, then t square alpha r square, example t square upon r cube is equal to constant is equal to k. For simplicity, we shall assume the orbit to be a circle. In the figure 1.6, S denotes the position of the sun, P denotes the position of a planet at a given instant, and r denotes the radius of the orbit is equal to the distance of the planet from the sun. Here, the speed of the planet is uniform, circular motion of a planet around the sun. V is equal to circumference of the circle upon period of revolution of the planet is equal to 2 pi r upon t. If m is the mass of planet, the centripetal force exerted on the planet by the sun is equal to gravitational force. So F is equal to mv square upon r. That's why F is equal to m into 2 pi r into t square upon r is equal to 4 pi square m r square upon t square into r is equal to 4 into pi r square into m into r upon t square. According to Kepler's third law, t square is equal to kr cube. That's why F is equal to 4 pi square m into r upon kr cube is equal to 4 pi square m upon k. So in bracket 1 upon r square. Thus, F alpha 1 upon r square as 4 pi square m upon k is constant in a particular case. D. A stone thrown vertically upwards with initial velocity u reaches a height h before coming down. Show that the time taken to go up is same as the time taken to come down. We have v is equal to u plus at and s is equal to ut plus 1 upon 2 at square. हे दोन्ही सुद्धा समीकरण आहेत. That's why s is equal to v minus at t plus a upon 2 at square, that is equal to vt minus at square plus 1 upon 2 at square. That's why s is equal to vt minus 1 upon 2 at square. As the stone moves upward from A to B, s is equal to ab is equal to h, t is equal to t1, a is equal to minus g. Retardation, u is equal to u and v is equal to 0. That's why from equation 3, h is equal to 0 minus 1 upon 2 minus g t1 square. That's why h is equal to 1 upon 2 gt1 square is the fourth equation. As the stone moves downwards from B to A, t is equal to t2, u is equal to 0, s is equal to h and a is equal to g. That's why from equation second, h is equal to 1 upon 2 gt square. It's the fifth equation. And from equation 4 and 5th, t1 square is equal to t2 square. That's why t1 is equal to t2. t1 and t2 are positive. E. If the value of g suddenly becomes twice as its value, it will become 2 times more difficult to pull an object along the floor. Why? Answer. To pull an object along the floor, it is necessary to do work against the force of friction between an object and the surface of the floor. This force of friction is proportional to the weight mg of the object. If the value of g becomes twice its value, the weight of the object, and hence the force of friction will become double. Therefore, it will become 2 times more difficult to pull a heavy object along the floor. Third, explain why the value of g is 0 at the center of the earth. Answer. The value of g changes while going deep inside the earth. It goes on decreasing as we go from the earth's surface towards the earth's center. We shall treat the earth as a sphere of uniform density. If we consider a particle of mass m at point P at a distance r minus d from the earth's center, where r is the radius of the earth and d is the depth below the earth's surface, the gravitational force on the particle due to the earth is F is equal to gm m dash upon r minus g square. M radius is equal to r minus g. M dash is equal to 4 upon 3 pi in bracket r minus d cube into m upon 4 upon 3 pi r cube is equal to m in bracket r minus d cube upon r cube. Because the outer spherical shell is not effective, figure 1.10, in this case the acceleration due to gravity is where m is the mass of the earth. Thus, g decreases as d increases. It is less than that at the earth's surface. So, in bracket gm upon r square at the earth's center, d is equal to r. So, g is equal to 0. Question 4. Let the period of revolution of a planet at a distance r from a star be t. Prove that if it was a distance of 2r from the star, its period of revolution will be 8 under square t. Answer. T is equal to 2 pi upon under square gm r3 into 2, where T is equal to period of revolution of a planet around the sun, m is equal to mass of the sun, g is equal to gravitational constant, and r is equal to radius of the orbit, assumed to be circular, is equal to distance of the planet from the sun. For r is equal to r and t is equal to t1. That's why t1 is equal to 2 pi upon under square gm r3 into 2. For r is equal to 2r and t is equal to t2. That's why t2 is equal to 2 pi upon under square gm into in bracket 2r upon 3 upon 2 is equal to 2 pi upon under root gm r 3 upon 2 into 2 3 upon 2 that is equal to t1 into 2 upon 3 into 2. That's why t2 is equal to t1 under square 8 is equal to under square 8t. Fifth, solve the following examples. A. An object takes 5 seconds to reach the ground from a height of 5 meters on a planet. What is the value of g on the planet? Solution. Data. U is equal to 0 meter per second, S is equal to 5 meter, T is equal to 5 seconds, G is equal to what? That's why S is equal to 1 upon 2 gt square. That's why 5 meter is equal to 1 upon 2 g into in bracket 5 seconds square is equal to 1 upon 2 g into 5 second into 5 second. That's why G is equal to 2.2 upon 5 ms square is equal to 0.4 ms square on the planet. B. The radius of planet A is half the radius of planet B. If the mass of A is ma, what must be the mass of B so that the value of G on B is half that of its value on A? Solution. Data. RA is equal to RB into 2, GB is equal to 1 upon 2 GA, and MB is equal to what? G is equal to GM upon R square. That's why GA is equal to GMA upon R square A, and GB is equal to GMB upon R square B, RB square. That's why GB upon GA is equal to in bracket MB upon MA into RA upon RB square. That's why 1 upon 2 is equal to MB upon MA in brackets into in bracket 1 upon 2 square is equal to 1 upon 4 MB upon MA. That's why MB upon MA is equal to 4 upon 2 is equal to 2. MB is equal to 2 MA. C. The mass and weight of an object on the earth are 5 kg and 49 Newton respectively. What will be their values on the moon? Assume that the acceleration due to gravity on the moon is 1 upon 6th of that on the earth. Data. M is equal to 5 kg, W is equal to 49 Newton. Gm is equal to G upon 6m on the moon is equal to what? And W on the moon is equal to what? First, the mass of the object on the moon is equal to the mass of the object on the earth is 5 kg. Second, W is equal to mg. Then that's why Wm upon W is equal to Wm म्हणजे moonचं weight आणि We म्हणजे earthचं weight. Wm upon We is equal to mgm upon mge is equal to gm upon ge is equal to 1 upon 6. That's why Wm is equal to We upon 6 is equal to 49 Newton upon 6 is equal to 8.167 Newton. D. An object thrown vertically upwards reaches a height of 500 meters. What was its initial velocity? How long will the object take to come back to the earth? Assume G is equal to 10 meters per second square. Solution. 100 milliseconds and 20 seconds. E. A ball falls off a table and reaches its ground in 1 second. Assuming G is equal to 10 meters per second square. Calculate its speed on reaching the ground and the height of the table. Solution. Data. T is equal to 1 second. G is equal to 10 meters per second square. U is equal to 0 ms. S is equal to what and V is equal to what? First, S is equal to UT plus GT ut plus 1 upon 2 gt square is equal to 1 upon 2 gt square for u 0 meter per second. That's why s is equal to 1 upon 2 into 10 ms square into 1 second square is equal to 5 meter. The height of the table is 5 meter. Second, v is equal to u plus at is equal to u plus gt is equal to 0 meter per second plus 10 meter per second square into 1 second is equal to 10 meter per second. The velocity of the ball on reaching the ground is equal to 10 meter per second. F. The masses of the earth and moon are 6 into 10 raised to 24 kg and 7.4 into 10 raised to 22 kg respectively. The distance between them is 3.84 into 10 raised to 5 km. Calculate the gravitational force of attraction between the two. Use G is equal to 6.7 into 10 raised to minus 11 nm square into kg square. Solution. M1 is equal to 6 into 10 raised to 24 kg. M2 is equal to 7.4 into 10 raised to 22 kg. R is equal to 3.84 into 10 raised to 5 km is equal to 3.84 into 10 raised to 8 meter. G is equal to 6.7 into 10 raised to minus 11 nm square into kg minus 2. F is equal to what? F is equal to gm upon gm into gm2 upon r square. That's why 6.7 into 10 raised to minus 11 nm square kg minus 2 into 6 into 10 raised to 24 kg into 7.4 into 10 raised to 22 kg upon 3.84 into 10 raised to 8 meter in bracket 2 is equal to 6.7 into 6 into 7.4 into 10 raised to 35 upon 3.84 into 10 raised to 16. N is equal to 2.017 into 10 raised to 20 Newton. This is the magnitude of the gravitational force between the earth and the moon. G. The mass of the earth is 6 into 10 raised to 24 kg. The distance between earth and the sun is 1.5 into 10 raised to 11 meter. If the gravitational force between the two is 3.5 into 10 raised to 22 Newton, what is the mass of the sun? Use G is equal to 6.7 into 10 raised to minus 11 nm square into kg minus 2. Solution. Data. M1 is equal to 6 into 10 raised to 24 kg. R is equal to 1.5 into 10 raised to 11. F is equal to 3.5 into 10 raised to 22 Newton. G is equal to 6.7 into 10 raised to minus 11 nm square into kg square. Then M2 is equal to what? F is equal to gm1 into m2 upon r square. That's why m2 is equal to fr square upon gm1 is equal to 3.5 into 10 raised to 22 Newton into 1.5 into 10 raised to 11 m square upon g 6.7 into 10 raised to minus 11 nm square into kg minus 2 into 6 into 10 raised to 24 kg is equal to 3.5 into 1.5 into 1.5 into 10 raised to 44 kg upon 6.7 into 6 into 10 raised to 13 is equal to 1.96 into 1030 kg mass of the sun. आता project पाहूया. Take weights of 5 of your friend. Find out what their weights will be on the moon and the Mars. Answer. Help the weight of a body. First आहे on the earth W1 is equal to mg1. Second on the moon W2 is equal to mg2. Third on Mars म्हणजेच W3 is equal to mg3. That's why W2 is equal to W1 into G square, G2 upon G1, and W3 is equal to W1 is into G3 upon G1. Now G1 is equal to 9.81 ms square, G2 is equal to 1.67 meter per second square, and G3 is equal to 3.72 meter per second square. If W1 is equal to 500 Newton and W2 is equal to 500 into 1.679 upon 81 Newton is equal to 85.12 Newton approximate, and the weight 3 is equal to 500 into 3.729 upon 81 Newton is equal to 189.6 Newton approx. तर अशा प्रकारे आपला फर्स्ट लेसनचा एक्सरसाइज संपली आहे. आपण प्रोजेक्ट पण केलेला आहे. तुमच्या मित्रांची वजनं वेगळी असेल तर तुम्ही वेगळे वजनं घेऊन सुद्धा हा प्रोजेक्ट कंप्लीट करू शकता. व्हिडिओ बघितल्याबद्दल धन्यवाद. व्हिडिओ आवडला असेल तर लाईक करा, तुमच्या मित्रमैत्रिणींना शेअर करा आणि सपनाज होमस्कूलिंग चॅनलला सबस्क्राईब करायला विसरू नका. धन्यवाद.